today we'll be learning the second half of chapter 4, lesson 6. Okay, still talking about functions. Function notation is a form that you often see functions written in. Okay, it's a rule for a function in which you use the symbol f of x, is how that's read, instead of y. And this is read f of x. It's telling you the function of x, right? Instead of your output saying the function of x, right? So here we have an equation like we've seen before, y equals 2x minus 3. In function notation, you should see that the only difference is instead of using y, they wrote it with f of x, right? Saying if we plug in x, we will get an output, right? Evaluating a function. This is nothing new, just like I said, now these are going to be written in that function notation. We substitute for x or f of x and solve, right? We can sub in for x like we always have, or we can sub in for that f of x, which is the same as subbing in for y, right? So it says the function w of x equals 250x. Represent the number of words w of x you can read in x minutes. How many words can you read in 6 minutes? So they first wanted me to write a rule in function notation, right? Or they already wrote me the rule in function notation. They want me to solve that rule with an answer or an input of 6 minutes. So I have w of x equals 250x. They're telling me right here that x is 6 minutes. So I need to substitute 6 minutes in for x, okay? So we're going to take 250 times x, which is 6. And the words, okay, they can read in 6 minutes is 1,500. Okay? And actually, lots of times when you write these, you'll actually plug in the 6 for this x as well. Okay, so we're saying the function when solved for 6 is this. Okay, so it was asking for how many words you can read in 6 minutes. The answer is 1,500 words. Okay, so you're still just evaluating. Function notation is still just an equation, just that f of x is representing a single term, single variable. So let's look at some more of those. Okay, so lots of times when they ask you to evaluate, they're asking you to find the range, because remember that range is your output of a function, right? Which is your y's values. Just now we're calling it f of x. And it doesn't have to be an f, it can be any variable of x or of any other letter, as long as it's telling you it's a function, right? So when they're asking you to find the range, they're going to ask you to substitute whatever numbers they give you for the domain and solve your equation. Okay, so it says the domain of the function g of x equals 4x minus 12 is 1, 3, 5, and 7. What is the range? So what they're asking me to do is substitute in 1 and solve, substitute 3 and solve, substitute 5 and solve, and to substitute 7 and solve. Okay, so I've already written those equations out. Okay, so to solve them, I just solve them like normal. Okay, 4 times 1 is 4, 4 minus 12. Okay, so g of 1 equals negative 8. G of 3 means I have 4 times 3 minus 12. 4 times 3 is 12. 12 minus 12 gives me g of 3 is 0. Okay, so the function g when x is 3 is 0 is what that's telling us. G of 5, so I have 4 times 5 minus 12. So 4 times 5 is 20. 20 minus 12 tells me the function g when x is 5 is 8. Okay. G of 7 means 4 times 7 minus 12. Well, 4 times 7 is 28 minus 12. So g when x is 7 is 16. So to finish answering that question, then they asked me what the range was. I need to make sure I identify that answer completely. So my range, and remember a range is a type of set, so we need it inside those braces, is -8, 0, 8, and 16. Okay. Least to greatest, okay. Subbing in those numbers, or plugging in those numbers we got for our outputs. Domain and range, remember, domain's your x values, range is your y values, okay? But in real life, most events, again, do not include negative numbers. And when that happens, they're said to have a set or a limited domain. Limited or set domain, okay? And these look different, okay? Most graphs we do and we've worked on, okay, if they don't tell us anything about that domain and range, okay, is an arrow or a line with arrows at both ends. So this is no limits. Great handwriting there. No limits and no set domain. Okay. Then we have an arrow. Okay. But if it is limited or set, okay, we either have array or a segment. Okay. And array, remember, it's a dot at one end and keeps on going in one direction. Okay. And what that will look like is this right here. Okay. Your domain will be a set saying that the function's values of x, okay, here can be greater than 2. So this dot would be where x equals 2 and would keep going that way. Okay. If it was less than 2, it would start at the 2 and point the other way. Okay. And we'll try some of these in a minute. Okay. Segment domain means you're going to have an end statement for your domain. Okay. So the values of x, and they have a line there, x can be between -2 and 8. Okay. Should have equals there. But it doesn't really make a difference for this. But so here we have a dot at -2 and a dot wherever our 8 was for x, and we connect them. So let's look at these. Determine if the following is a limited or set domain and tell what the graph will look like. Okay? So here our domain is 2, 4, and 6. This is a very set domain. Okay? It's completely limited to only 3 values. Okay? Set domain. Okay? And for this one, if x can only be those values, what that means is that this is only going to be dots on a graph. Okay, we're not actually going to connect them at all because they're saying it can't be 2.5, it can't be 3. Okay, so it's only going to be those exact dots. Okay? Where your domain is all real numbers, this is the type we usually have been working with. Okay, we get to pick whatever numbers we want to solve for that. Okay, so this one would be a line on a graph. Okay, but this right here would be an unlimited domain. Okay, they're not saying it can only be certain things. Okay, for this one, okay, this one they're saying x has to be greater than 3, so this again is a limited or set, either word you want to use. Okay? And since this one's only going in one direction, our graph would be array. And if you want to be more specific, since x has to be bigger than 3, okay, it would actually have a dot at 3, and then it would keep going up. Okay, remember that would be on your x-axis. Okay? This one here, again, it tells me it can be -3, or it's between -3 and 8. So for this one, it is again a limited or set. Okay? And our graph would be a segment. Oh my goodness. those are the different types of domains you'll see. And so you have to really think still, is our graphs going to be a line, array, or a segment? And again, for word problems and real life situations, most of the time they're either just going to be array or a segment. So let's look at a real life example of a function. Okay. You have 7 quarts of paint to paint the trim in your house. A quart of paint costs or covers 100 square feet. The function a of q equals 100 q represents the area by a of q in square feet that q quarts of paint can cover. What domain and range are reasonable for the function? Okay. Well, what we know.
Chelsea Grafstead.
So what we know is I can choose not to paint at all. Okay? And if I don't paint, I use 0 quarts. Okay? So that's our least we can use for our domain. Okay? It's the smallest amount of paint we can use is nothing. Okay? The greatest, since I only have 7 quarts, that means that's the most paint I can use. Right? So 7 is the greatest value for our domain. Okay? So what that means is our domain is going to look like this. Q, okay, is in the middle. It can be between 0 and 7. Okay? And it can be those amounts, so it's or equal to. Okay? So 0 is less than or equal to Q, which is less than or equal to 7. Anytime it's between 2 numbers, you're writing that AND statement. Okay? So that's your domain. But for our range, we actually have to substitute in those values to our function and solve. Okay? So if I'm solving a of 0, okay, remember I'm plugging in that 0 where the x's were, in this case q's. So a of 0, the area can be covered by 0 quarts, would be 100 times 0. So a of 0 is 0. So the smallest amount for my range is going to be 0 square feet. Okay? The greatest amount for the domain was 7. So I want to know the area when I use 7 quarts of paint. So I just substitute that 7 in for the Q, which means I'm taking 100 times 7. So A of 7 is 700. Okay? So these two output values, the 0 and my 700, are the amounts I can use for my range. Okay? The outputs when you sub in your smallest domain and your smallest or your biggest domain. So the reasonable range is that I can paint 0 square feet to 700 square feet. Okay. So what would that look like on a graph? Remember thinking about is a set domain or a limited domain? Okay. It's going to be a segment because it's between 2 values. So our graph would have a dot at one end, a dot at the other end. This dot would be at 0. This dot right here would be at 7. So when you were thinking about your graph, this is how it would look. 7, 6, 5, 4, 3, 2, and 1. That's my domain from my x. Whereas my range, this dot right here, has to be represented at 700. Okay, so my range, my y's, are going to go from 100, 200, 300, 400, 500, 600, and we're at our 700. And if you want to put an extra value on there, you can, but your graph would definitely only be a segment because we
Extension 3003. Thank you.
on both parts. Okay, so that's what you're going to be working on today. Okay, identifying function notation. Okay, so you're going to be solving functions that are written with that f of x or g of x or p of x or p of n, okay, instead of that y. Solving and evaluating functions where you just really are substituting in wherever you see that x value in your function notation. Okay. Make sure again, if it asks you what's the range, you write that range in that set form where you have it in the braces. Right? And when you're doing your word problems today, think about, is it going to be a line, array, or a segment?